So if you guys go to the first page of the horizontal curve note, you'll see those two equations that are specific for a 100-foot long chord and a 100-foot long arc. They are a little bit different. So I think that was the biggest issue with this. So I have both examples here for reference. So again, if you have a 100-foot long chord, and again, this equation I am writing is only applicable to a 100-foot long chord. If you have a chord that is a different length, or if you're given an arc, this equation is not going to be applicable. The equation is that your radius r is equal to 50 divided by sine of d over 2. So d is going to be the degree of curvature. That's essentially what you were looking for. So we can rewrite this using our variables. So we're given a radius of 300 feet. So we can rewrite this as 300 is equal to 50 times sine of d over 2. And we can solve for sine of d over 2 is equal to 50 over 300, and we can solve for d, and again, d is 19 degrees, 11 minutes, and 17 seconds. So again, you would take the arc sine of 50 over 300 and multiply that by 2 to get this answer. So if you were given a chord, that would be the procedure that you would use. If you are given an arc, you have a different equation. By definition, for a 100-foot long arc, your radius r is equal to 5729.58 divided by d. So again, this 5729.58 takes into account the circumference of your circle. It takes into account that 2 pi. D again is going to be the degree of curvature. So for this example, again, you have a radius of 300 feet. And I just realized I think I forgot to publish your exam comments. After I write this in, I will do that for you. So we can rewrite this as 300 is equal to 5729.58. And you can solve for d as 19 degrees, 5 minutes, and 55 seconds. So give me 1 second while I go to your class. And amongst all the other things I was doing in Canvas, it got away from me to actually make sure you guys can see the correct solutions and comments for this one. Okay, so you guys should be able to see your comments if you refresh Canvas. But are there any questions on how we solve for the first problem that you guys had? So again, on your final, make sure that you actually read the question and answer the question that you're asked, because even if I was to grade this and gave partial credit, you couldn't get partial credit if you solve for an arc when you're asked for a chord or vice versa. So just make sure that you're actually reading the question and answering the question that's asked, not the question that you think I'm asking or the question that you want to answer. Okay, so for question number 2. So a length of a horizontal curve, so you're given that length of 513.6, you're given a radius of 600. This should have been 600.0 feet for proper sig figs, but it didn't really matter because we're looking for something in terms of degrees, minutes, and seconds. It should not have impacted your final answer. Determine the internal angle of the curve. Represent your angle as xx degrees, xx minutes, and xx seconds. So we have 2 variables. We have L and we have R, and we want to find I. So the equation that relates all 3 of these together, and I'm just going to put a little I here because it's easier to see, but L is equal to R times I. So again, L, 513.6 is equal to my radius of 600 times my angle I. And I can solve for that angle, and I get 0.856. This is in terms of radians, and you're looking for your answer in terms of degrees, minutes, and seconds. So I need to convert this into degrees. So I can multiply by 360 and divide by 2 times pi and get a final angle of 49 degrees, 2 minutes, and 43 seconds. So as a reminder, whenever you're using this equation, I is in radians, so you have to make that conversion. Questions about that problem? Okay, so for the next problem, you're given a radius of 435. You're given that angle I of 38 degrees, 20 minutes, and you want to find your tangent length. So again, I go to my equations, and I find out that I have an equation that relates my tangent length, my radius, and my angle I. Whoops. So again, I'm looking for my tangent length t. That's going to be unknown. So my radius is 435. And I'm going to multiply that by tangent of my angle I, 38 degrees and 20 minutes, divided by 2. And that should give me a final answer, 151.2. Again, I have 1 decimal place here, so there should be 1 decimal place in my final answer. Questions about that problem?
I doesn't have to be in radians?
No, because you're taking a tangent. So as a general rule of thumb, wherever you're taking your sine, cosine, tangent, your calculator should be set for this class in terms of degrees, not radians. So if I converted this to radians, I would also have to make sure that my calculator was in radians. So the only conversion to radians is going to be with this equation. So whenever you have this equation, this I is in radians, so you want to make sure that you convert this I to degrees, minutes, and seconds. Everything else, your calculator for this class always has been or always should have been in degrees, minutes, seconds, or in terms of degrees. So yeah, the only conversion you should have to do is for this equation. Does it answer your question? I think that was Eric.
Yes, thank you.
Okay, yeah, so when you guys are preparing your notes for your final, big red note there, right? Make sure I convert into or this is in radians, make sure I convert into degree, but everything else can be in degrees. Okay, the next question, there was a typo in here, but it does not affect the final answer, but the numbers theoretically don't make sense. We have a horizontal curve with a PI station of 4215. A length of the horizontal curve is 2,400 feet and the tangent length is 315.7. I can tell you right now, if you have a tangent length of 315.7, you can't have a horizontal curve length of 240. But regardless, it doesn't impact the final answer. Just geometry-wise, this would never be realistic. Okay, so there were some issues on this, and I think I know where the issues are coming from. So my beginning of my curve station plus a tangent length t is always going to be equal to my PI station. My BC station plus the length of my curve is always going to be equal to my EC station. So PI stations are along tangent lengths, and a curve station is relating that horizontal curve. So the EC station is not equal to my PI station plus T. And I think a handful of students, potentially more, took my PI station given an added tangent link to get to the EC station. That is not the correct answer. So as a general rule, the EC station is relating the BC and the length of that horizontal curve. So again, historically on finals, I've seen students do this incorrectly. So again, another note probably to have on your horizontal note sheet that the PI stations, I can add my tangent lengths, but for my EC station, I need to go for my BC station. So with that being said, for this particular one, I'm going to have my PI station, and I am going to subtract my tangent length to get to my beginning of my curve station. So my PI station, again, I'm using my brackets for stations. I have 42 plus 15. Again, I'm just not writing all my decimals. And I am going to subtract 315.7. And give me a second because I don't have the intermediate number here. 3899.3. So this should yield that my beginning of my curve station is equal to 38 plus 99.3. So if I take that beginning of my curve station again, using brackets to indicate my station, plus the length of my curve, again, 2,400 feet, that should give me a final EC station of 62 plus 99.3. So your final answer is not 4215 plus 315.7. You need to subtract that out to get to your BC and then add the length to get to your EC. Again, numbers aren't realistic, but I don't think it caused anyone to get the answer wrong. I think what I saw more than anything was people adding 4215 plus 315.7. Questions about that concept? Okay. So the next one is for our double meridian distance. So you may have been given different numbers, but everyone was asked to find the double meridian course of BC. So by definition, the double meridian distance is going to be the departure, or sorry, let me do this in order. I'm going to take the double meridian distance of my previous course, that's going to be course AB, plus the departure of my previous course. Again, that's course AB, plus the departure of the current course, and that's going to be course BC. By definition, your first course at double meridian distance is always going to be equal to that departure. So for our problem here, where I was given or asked to find double meridian distance of BC, I'm going to take my double meridian distance to my previous course, AB. Again, that's just my departure. Include all of your positive and negative signs as appropriate. I'm going to add to that my departure of the previous course, AB. Happens to be a negative value. And then I'm going to add to that the departure of my current course. And you should get, whoops, negative 537.1. So Again, if you had different values, this is still going to be the general equation that you're going to use. Everything was provided in terms of 1 decimal, so your final answer should be in terms of 1 decimal. Any questions about that problem or other problems on this quiz? Okay, so if you guys don't have questions on this, as usual, I will upload this document after class today. So let's go back to part 13 of the notes. We're only going to spend a couple minutes on this, and then we'll talk about the final. So there was a math error on the bottom of page 10. Yeah, so you should be able to see your quiz now. I unlocked it, so refresh Canvas. I unlocked it right after I did the first problem. So there was, this should have been squared, and so there was a math error. So the final answer should have been 18.3 stations or 1830 feet, larger than my curve. So make sure that you guys get that data corrected on your notes. Okay, so the next few pages are really there for your reference. So you guys are going to be taking the transportation class of 140 class, and in that class you guys are going to be talking a lot more about horizontal curves, vertical curves, safe distances, why curves need to be certain lengths, and what have you. These are a little bit old, but the concept hasn't changed. So for every design speed, there's going to be essentially a minimum length of the curve based on that design speed and based on your grades. So on the vertical axis here, you have your algebraic difference in your grades. This is the difference between G1 and G2. Basically add them together and take the absolute value. And you have a design speed. Well, you can see that as my design speed increases, I'm going to need longer vertical curves. This is basically going to be my minimum length, the dashed line here. So again, my grades are also impacting that. So I need to take a look at both of my design speed and my grades in order to determine what that minimum is going to be. So again, typically as I go up in my grades, I'm going to have longer and longer and longer vertical curves. This is for a sag curve. There's a similar one here for a crest curve. If you just look at the bottom numbers, this goes from 200 to 2000. This goes from 200 to 3000. Sight is a little bit more critical when you have a crest curve, so that sight distance gets a little bit longer with the same speed. And again, your passing distance, sight distance is here as well. This table up here has your design speeds, your sight distance, and then your stopping distance is provided over here. So you can see the sight distance is typically more critical than that stopping distance. And that's going to be true for all of these. Okay, so again, these are provided for your reference. All right, so let's talk about your final. Okay, so if you log in to Canvas, everything you have submitted should be graded. There is also a grade there for your attendance and participation. subject to change based on whether or not you attend this week. If you do not agree with any of the scores that are currently on Canvas, you need to send me an email. Do not post a notice on Canvas. I will not see it. Send me an email to my email address and be specific. Include your class, section number, explicitly what quiz, homework, attendance, and participation that you don't agree with, and I can review it. But don't just have a very general statement. So it needs to be, for example, on homework number 3, I lost 2 points on problem 4. But I have shown this, it matches the solution. Be specific. If you're just general, I can't really help you. I will accept any emails until this Friday. So if you have any questions about your grade, email me by this Friday. After this Friday, I have 200 finals to grade. I have projects to grade in some of my classes. That is not a time to dispute your grade. So I spent this past weekend making sure everything was uploaded for 200 students. You guys can find 5 minutes between now and Friday to verify that your grades are correct. Once your grades are there, they're there. It is what it is. In order to be guaranteed to pass this class, you have to have a minimum of a 57% going into the final. So if you have a 57% going into the final and you can somehow manage to get 100% on the final exam, you would get a 70% in the class and be guaranteed a C-. If you have less than a 57% currently, you cannot reach a 70%. There may be a curve in this class. There may not. I can't guarantee it. But that curve isn't going to be a 60% passing. It's probably not going to be a 65% passing. It may go down to like a 68%. May. Not guaranteed. The only way you can guarantee to pass this class is with the 70%. So I cannot evaluate a curve until all CE9 students have taken their final and I can look at all of the scores. So in order to be guaranteed to pass this class, you need a 57% going into the final. I've already added some extra points for homework and quizzes, and you may get a couple more homework grades. I did it before the last homework was graded. That kind of accounts for maybe a problem was difficult, the grader graded too hard, what have you. That's kind of the curve for your homework and your quizzes. There is no curve for individual exams because I have essentially perfect scores on every exam in this class. So I based that extra points based on the most number of points any student in the class got, based on the number of available. So for the exams, it's 0 because people got perfect scores on the exam. So there is no curve on the exam. As a general rule, I do not curve an A. So to get an A, you need a 90%. I will tend to maybe curve a B or a C, but again, a curve is not guaranteed. It depends on how all CE9 students do on the final. Okay, so if you guys log into your Canvas, you will see up there, you'll see a Zoom session for your final exam. You guys will also see that there is currently a final exam upload. I made it out of 1 point. Ultimately, it's going to be out of 0, but some students in other classes wanted me to have something so they could mess around with their grade. Do what you want with it. Ultimately, it's going to be worth 0 points. So your final exam per the university schedule is going to be next Tuesday, December 14th from 10:15 to 12:15 a.m. 10:15 a.m. to 12:15 p.m., I should say. I'm trying to type in. And I see that someone's emailing me during class. Please don't ask me questions about what I'm talking about if you're going through your stuff right now. I'm hoping that you're paying attention because this can mean the difference between you passing and not. I'm not saying for that individual student, but I think you kind of need to pay attention about what's on the final, what you guys need. So as usual, log into Zoom. You'll have to turn on your video. Once your video is turned on, I will give you a passcode to take the exam. There is going to be a combination of short answer and workout problems. I don't know how many times I can say this. Read the question and answer the question you are asked. On previous exams, students have done way too much work. So if I only ask you for course BC, that's the only thing I want you to solve. You're not going to earn any more points by showing me you know how to do the same calculations for additional courses, or what, just as an example. Whatever the issue is, answer the question that you are asked. No more, no less. Sorry, there we go. So on the workout problems, show all of your work for partial credit. So if you just give me a final answer and I have no idea how you got there, that's not showing knowledge of the problem. You're not going to gain any credit for that. There are a few exceptions. Obviously, if you have a table that has departures and latitudes and you say the sum of the departures is this and the sum of the latitudes is that, and you don't show your work, that's totally fine. But when you start using equations, I need to know what equation and variables you're using. So if you're using L is equal to RI, you don't necessarily have to write L is equal to RI, but you have to write out that equation with variables so I can see what equation you're using and what variables you're using. So if you get the incorrect answer and you have all of the correct variables in there, you're going to get most of the points. On the other hand, if you don't use the correct equation, you don't get any points. So again, just to make sure that you're actually showing all of your work. So if you're not showing your work, I can't really help you. Oops. So again, if you're asked to upload your work, upload your work. The only time I need you to type an answer into the box is for the short answer problems. So if I just want you to give me a final answer, give me a final answer. Final answers have to have the correct sig figs. As you guys have noticed on the quizzes, I'm getting a little bit more lenient on how many points I'm taking off. At the beginning, I took off more points than I am later in the semester, hoping people would have kind of gotten the clue that you are going to miss points. But again, on the final, if you don't have appropriate sig figs, points will be deducted, even on the workout type problem. So make sure that your final answers have the correct number of significant figures. I think most students are pretty good with this, but angles, again, for a final angle need to be in degrees, minutes, and seconds. So again, if I don't provide you seconds, don't provide seconds in the final answer. Okay, that's kind of, oh, one more thing. So I have not written your final yet. I don't know how many points it's going to be worth exactly. I don't know how many problems it is. But the total number of points is going to be approximately, not exactly, approximately 70 points. So it might be 65, it might be 75, somewhere in that range. So if you have a 50-minute class and you are looking at a 30-point exam, once I go to a 120-minute exam, I've basically ratioed it and get about 70 points. So again, I'm not expecting people as a whole to leave early. The exam is intended to basically take you the entire time unless you're really quick and know what you're doing. For time management, I know a lot of students are having problems with time management, not completing the exam. Each point equates to approximately 1.5 minutes. So if I have a 10-point problem, that should be taking me about 15 minutes. If I have a 2-point problem, I should be looking at 3 to 4 minutes. If I'm not doing my problems in that time frame, I'm probably not going to finish the exam. And again, some of you guys will do that work much quicker and you will finish early, but I think that will be a handful of students. Okay, general questions on the general thing. We'll talk about specifics and what type of problems, but any general questions? All right, so you guys are going to be guaranteed a problem on area. So we have area of a closed traverse. I will give you a problem. I will not tell you what method to use, meaning you can pick and choose what method makes sense for you. Does it make sense to use geometry? Does it make sense to use a coordinate method? Does it make sense to use a double meridian distance method? That's going to be based on the information that's provided. So even though I won't tell you to use a double meridian distance, I may ask you what the double meridian distance for a course is. So you still have to know how to calculate a double meridian distance, but that does not mean that you have to solve the area method using a double meridian distance. And hopefully, based on the information provided, it will be clear what the shortest answer method is for that particular problem. So this is going to be a workout problem. Oops. You're going to be given a horizontal curve problem. Again, that's going to be a workout problem. It will be no more difficult than what you had on your homework. It will not be a super long problem, meaning I'm not going to give you like 3 or 4 different curves with different radius that you need to solve. But you can have a reverse curve. You can have a compound curve. You can have 2 curves that are separated by a straight line distance. Read the question and make sure you understand what information is given. Again, if you guys have questions as we're going through, feel free to ask. And the other thing you are guaranteed to see is a vertical curve. So for the vertical curve, having taught this class for a lot of years and having not historically assigned this as a problems that you guys have to hand in, sometimes we do, sometimes we don't. Typically in the fall, we don't because Thanksgiving just messes with everything at the end of the semester. Make sure you review your notes, and I've uploaded homework number 10. Homework number 10, you're not going to hand in. The homework and the solutions are posted. If I want to make sure I know how to do a vertical curve problem, I'm going to look at the problems that are on the first sheet, and I'm going to try to solve them, and I'm going to compare to my solutions. You need to put the effort in. A vertical curve is not a difficult problem, but historically has been a very low scoring problem on exams when I don't assign homework associated with it. So again, I'm assigning the homework, you just don't have to hand it in. So make sure that you spend that time. So you are guaranteed these 3 workout problems. If each of these problems is worth about 10 points, which is approximately what it's going to be worth. Again, it may be a little bit more, a little bit less, but you're looking about 30 points from these 3 problems out of a total of 70. So that's getting pretty close to about half of your score on your final is coming from these components that we haven't been tested on before. Any questions on those items? Okay. You guys have an exam. The Monday, Wednesday class has an exam. Your exams are different. I've told them not to talk to you. Their exam is on Monday. Yours is on Tuesday. I'm telling you guys, don't talk to them. It doesn't do anybody any favors. And if they listened to me yesterday, the curve is for both sections. And so if they give you guys information and your grades are higher, that only hurts them. So there's no reason for them to talk to you. But again, you asking them questions is also considered academic dishonesty. If any academic dishonesty is found, you will be reported to the university. So do your own work. All right, so within this class, again, your final is not going to be the same as your classmates. So there's going to be multiple questions that are going to be generated to ask a question of you. So other things that you can be asked. So again, these 3 are going to be guaranteed, but you can be asked elevation of a remote point, again, this would be a workout problem. Coordinate geometry. So there can be workout problems, there can be short answer problems, there can be both. So perpendicular distance from a line to a point, you would have that as a workout problem. Point of intersection of 2 lines, that would be a workout problem. That was on your last exam. So chances of that showing up again, probably less for this section than the other section, but it could happen. Not saying it can't, but chances are probably lower. Law of sines for triangles. So find unknown lengths, angles, whatever it is that you need to find. So coordinates, you can have XY coordinates and you can have northeast coordinates. Make sure that your format is consistent with the given data or the question that's asked. So if I ask for XY, provide me XY. If I ask for northeast, provide me northeast. So again, on the last exam, on some quizzes, even on labs I graded, I saw this. People switching up north and east, X and Y. North corresponds with your Y axis and east corresponds with your X axis. Again, you're going to use your latitude and departure to calculate what your coordinates are. Make sure that you have the appropriate positive and negative signs. So if I give you a length and an azimuth or bearing of a line, you should be able to calculate your latitude and departure. Again, appropriate positive and negative signs. And if I give you the latitude and departure, you should be able to calculate your length, azimuth, or bearing of a line. Whoops. I'm ahead of myself and my thoughts here. An azimuth is an angle between 0 and 360 degrees measured from your north arrow. I am still seeing issues with bearing. A bearing angle cannot be more than 90 degrees. It has to be between 0 and 90 degrees. And you also are going to have a quadrant direction. So again, northeast, northwest, southeast, southwest. You always have north or south, an angle, and then east or west. Equation of a line. That's the y is equal to mx plus b. Make sure that you can, again, find your slope. For that slope, there's a relationship with your azimuth or bearing. So if I give you an azimuth or bearing, you can calculate slope. And if I give you slope, you can calculate your azimuth or bearing. So you should know the relationship between them. I can ask you to create an equation of a line. I can ask you to use that equation of a line. So if I give you a point and I give you an X or a Y or a north or an east coordinate, you can find the other one. If I give you the equation of the line and I tell you it's so many feet long and I give you one coordinate, you should be able to find the other coordinate. So lots of different things I can ask you with relationship to that equation of a line. I have the azimuth and bearing up here, so I'm not going to repeat that. But again, you should know the difference between true and magnetic north. So if I give you true north, calculate magnetic and vice versa. I need to give you a declination in order to do that. Okay, so for your area problem, the traverse I give you will be a closed traverse, because the last thing I want to happen is to have a student close a traverse, close it incorrectly, and now all of a sudden their area is incorrect because the previous part was incorrect. So if you, not if, for your area problem, that traverse will be closed. However, you still do need to know how to close a traverse. So a couple things we talked about. The sum of the interior angles needs to be equal to n minus 2 times 180. So if that is not correct, I need to adjust those angles. So the large